Continuing our discussion of counting, last video we talked about permutations. Now we're going to look at combinations. These two things kind of go together. Recall that the salient points were that we're selecting things without replacement and the order is important. That's for permutations, and we had a formula. Now we can imagine if the order is not important. We're still selecting items without replacement. But if the order is not important, those outcomes are called combinations. And we have this notation NCR. Sometimes it's said N choose R. So recall from the example in the last video, we're selecting a committee of 3 with distinct roles, and those were permutations. Now we have a kind of a twist on that example. You're selecting 3 from 10 friends. Just to help you move, so the order is not important. They're not playing distinct roles, right? You just need 3 friends. Well, this is going to be a combination. Now, would you expect there to be fewer or greater than 720 ways to do this? Okay, so there are 720 permutations. Well, let's take a look. For a given combination, suppose you select these 3 friends. Well, those 3 friends give rise to 6 different permutations, right? 3 factorial. So given a collection of 3, those give you 3 factorial different permutations. So that suggests for the same combination, we get 3 factorial different permutations. So that suggests that we want to divide 10p3 by 3 factorial. So we'll get fewer different ways, fewer combinations. We get 120. So in general, 10c3, to get that, 10 choose 3, we're just going to divide 10p3 by 3 factorial. There's our formula here, and notice it's a nice formula because we've got the 10 and the 3 both appearing, and now we have a 3 factorial, extra 3 factorial appearing there, and here's our general formula, N choose R. Okay, so that's another formula that you'll have to remember. So let's take an example. In Powerball, you got 5 numbers, and they're balls labeled 1 to 69, and you just need to pick and match those 5 in any order. And let's forget about the Powerball for now. So since the order is not important, and it is without replacement, you have to know that. That's just how the game works. They don't put the ball back in the hopper, so it's without replacement important. So this is what we get. Now, how do we compute that? Well, we're not going to try to compute 69 factorial. It's a huge number. We'll do an example in class. So what we do is use a little bit of a trick here. So let's simplify the denominator here, and notice we have a 64 factorial in the denominator. So what we're going to do is use a trick to write 69 factorial in such a way as that it will cancel that 64 factorial. So here's our trick. We write 69 factorial this way, and we stop at 64 and put a factorial, right? Because 69 factorial is just the product of all these numbers, 64, 63, 62, all the way down to 321, right? And so that tail end of it is just 64 factorial. So if we do that, we can cancel this 64 factorial here with this one, right? 64 factorial. And if we do that, now we're left with more manageable numbers. So you can multiply these numbers out, and they're not too bad. 69 factorial, your calculator won't do it. Okay, so you wind up with, oops, there's a little typo here. So there shouldn't be this 64 factorial here down on the bottom, and this one should not appear. Those have canceled out. So in any case, we get this number here. That's the number of ways to match the 5 numbers, 11 million some odd. Okay. Now you can imagine another, if we do consider the Powerball, which is another number from 1 to 26, they pick that separately. So if you add that to the mix, how many different ways can you make the selection? Okay. You can also imagine the odds, or the probability of winning, right? So if we go back to this, the probability of winning is 1 divided by that number. Okay. So if you throw in the Powerball into the mix, how are you going to count the number of ways to do this? Well, here's your hint. Use the fundamental principle of counting. You know how many ways to select the 5 balls, and then there are going to be 26 ways to select the Powerball, so we would use the fundamental principle of counting. We'll look at an example in class. We'll follow up with this, and I'll see if you guys have any ideas of how to use the fundamental principle to answer this question.